Hello, and welcome to EduSciB Edutainment. In this video, we will be discussing important concepts in 10th class physics that every student must know. But before proceeding further, please subscribe our channel so that you may be notified for the future videos like this. Simple harmonic motion, SHM. When an object moves back and forth repeatedly in a straight line, it is called simple harmonic motion. The motion is caused by a restoring force that tries to bring the object back to its original position. Damped oscillations. When an object experiences friction or air resistance, its motion slows down gradually and eventually stops. This type of motion is called damped oscillation, where the amplitude of oscillation decreases over time. Wave motion. Wave motion refers to the transfer of energy through a medium without the actual transfer of matter. Waves can be of different types, such as sound waves, light waves, and water waves. Types of mechanical waves. Mechanical waves require a medium to propagate, and they can be of two types: transverse and longitudinal waves. In transverse waves, the particles of the medium move perpendicular to the direction of wave propagation, while in longitudinal waves, the particles move parallel to the direction of wave propagation. Ripple tank. A ripple tank is a scientific apparatus used to study the behavior of waves. It consists of a shallow tank of water where waves are created by a vibrating object, and their behavior can be observed using light or other means. Sound waves. Sound waves are vibrations that travel through the air and other mediums. These waves can be heard by our ears and are used to communicate and create music. Characteristics of sound. Sound has several characteristics, including pitch, high or low volume, loud or soft, and timbre, the quality of the sound. Reflection, echo of sound. When sound waves bounce off a surface and come back to our ears, we hear an echo. This is how we can tell how far away something is. Speed of sound. Sound travels at different speeds through different materials. It travels fastest through solids and slowest through gases. The speed of sound is around 343 meters per second in air at room temperature. Noise pollution. Noise pollution is when unwanted sounds, like traffic or construction noise, disrupt our environment and can harm our health. Importance of acoustics. Acoustics is the study of how sound behaves in different environments. It's important because it helps us design spaces that are comfortable to be in and optimize sound quality in music and theater. Audible frequency range. The audible frequency range is the range of frequencies that our ears can hear, which is typically between 20 Hz and 20,000 Hz. Ultrasound. Ultrasound is sound that has a frequency above the audible range, typically used in medical imaging to see inside the body without using radiation. Reflection of light. Reflection is when light waves bounce off a surface and change direction. This is how we see ourselves in a mirror. Spherical mirrors. Spherical mirrors are curved mirrors that have a spherical shape. There are two types: concave mirrors, curves inward, and convex mirrors, curves outward. Image location by spherical mirror formula. The formula for finding the location of an image in a spherical mirror depends on the type of mirror and the distance between the object and the mirror. Refraction of light. Refraction is when light waves bend as they pass through a material with a different density. This is why objects appear distorted when viewed through water. Total internal reflection. Total internal reflection is when light waves are completely reflected back into a material instead of being refracted out. This happens when the angle of incidence is greater than the critical angle. Applications of total internal reflection. Total internal reflection is used in fiber optics to transmit information through cables, and in prisms to split light into its different colors. Refraction through prism. A prism is a piece of glass or plastic that refracts light and separates it into its different colors. Lenses. Lenses are curved pieces of glass or plastic that refract light to form an image. There are two types: convex lenses, thick in the middle, and concave lenses, thin in the middle. Image formation by lenses. When light passes through a lens, it can form an image on the other side. The size and location of the image depends on the distance between the object and the lens. Image location by lens equation. The formula for finding the location of an image formed by a lens depends on the type of lens and the distance between the object and the lens. Applications of lenses. Lenses are used in cameras, eyeglasses, telescopes, and microscopes to form images and magnify objects. Simple microscope. A simple microscope is a single lens that magnifies an object by refracting light. It's used to magnify small objects, like insects or plant cells. Compound microscope. A compound microscope has two lenses that magnify an object. It's used to magnify very small objects, like bacteria or blood cells. Telescope. A telescope is an optical instrument that uses lenses or mirrors to magnify distant objects. It's used to study stars, planets, and other celestial bodies. The human eye. The human eye is an organ that collects light and sends signals to the brain, allowing us to see. It has a lens that refracts light and a retina that contains cells that detect light. Defects of vision. Defects of vision are problems with the way our eyes work that can cause blurry vision, difficulty seeing far or near objects, and other issues. These can be corrected with glasses, contact lenses, or surgery. Production of electric charges. Electric charges can be produced by rubbing two objects together, such as rubbing a balloon on your hair to make it stick, or by the flow of electrons in a wire. Electrostatic induction. Electrostatic induction is a process in which an object is charged without any direct contact with another charged object. This can happen when a charged object is brought close to a neutral object, causing a separation of charges in the neutral object. Electroscope. An electroscope is a device used to detect the presence of electric charges. It works by using a metal leaf or needle that is repelled by charges of the same sign and attracted to charges of the opposite sign. Coulomb's law. Coulomb's law states that the force between two electric charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Electric field and electric field intensity. An electric field is a region around an electric charge where other charged particles will experience a force. The strength of the electric field is measured by the electric field intensity. Electrostatic potential. Electrostatic potential is the amount of potential energy per unit charge at a point in an electric field. It is a measure of the work that would be required to move a unit charge from a reference point to the point in question. Capacitors and capacitance. A capacitor is a device used to store electric charge. Capacitance is a measure of a capacitor's ability to store charge, and it is determined by the geometry of the capacitor and the materials it is made of. Different types of capacitors. There are many different types of capacitors, including electrolytic capacitors, ceramic capacitors, and tantalum capacitors. Each type has different properties and is used for different purposes. Applications of electrostatics. Electrostatics has many practical applications, including in air purifiers, printers, and spray painting. It is also used in particle accelerators and in the study of the behavior of atoms and molecules. Some hazards of static electricity. Static electricity can be dangerous in certain situations, such as when handling flammable materials or in the presence of explosives. It can also cause damage to electronic equipment and can be a nuisance in industries such as printing and textiles. Electric current. Electric current is the flow of electric charges through a conductor. Think of it like water flowing through a pipe. Potential difference. Potential difference is the difference in electric potential between 2 points in a circuit. It is what makes the electric charges move through the conductor. Electromotive force, EMF. Electromotive force, EMF, is the energy that drives the electric current in a circuit. It is like the force that pushes water through a pipe. Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. This means that if you increase the voltage, the current will also increase. Characteristics of ohmic and non-ohmic conductors. Ohmic conductors have a constant resistance and their VI graph is a straight line, while non-ohmic conductors have a varying resistance and their VI graph is a curve. Factors affecting resistance. Resistance is affected by the length, thickness, and material of a conductor. Longer conductors have more resistance, while thicker conductors have less resistance. Some materials are better conductors than others. Conductors. Conductors are materials that allow electric charges to flow through them easily. Metals like copper and aluminum are good conductors. Insulators. Insulators are materials that do not allow electric charges to flow through them easily. Rubber and plastic are good insulators. Combination of resistors. Resistors can be combined in series, end-to-end, or in parallel, side by side, to create different levels of resistance in a circuit. Electrical energy and Joule's law. Joule's law states that the amount of heat produced in a conductor is directly proportional to the resistance, the current, and the time. This means that more heat is produced in a conductor with higher resistance, higher current, and longer time. Electric power. Electric power is the rate at which electric energy is transferred or used. It is measured in watts and is calculated by multiplying the voltage and current. Direct current and alternating current. Direct current, DC, flows in one direction, while alternating current, AC, flows back and forth. AC is used in most homes and buildings, while DC is used in batteries and electronic devices. Hazards of electricity. Electricity can be dangerous if not used properly. It can cause electric shock, burns, and even death. It is important to follow safety guidelines when using electricity. Safe use of electricity in homes. To use electricity safely in homes, make sure to use grounded outlets, unplug appliances when not in use, avoid using damaged cords or plugs, and never touch electrical appliances with wet hands. Magnetic effects of a steady current. A steady current flowing through a wire produces a magnetic field around the wire. This can be demonstrated by using a compass, which will be deflected when placed near the wire. Force on a current-carrying conductor placed in a magnetic field. When an electric current flows through a wire placed in a magnetic field, a force is exerted on the wire, which can cause it to move. Turning effect on a current-carrying coil in a magnetic field. When a current-carrying coil is placed in a magnetic field, it experiences a turning effect, which causes it to rotate. This is the principle behind electric motors. DC motor. A DC motor is a device that converts electrical energy into mechanical energy by using the principle of turning effect on a current-carrying coil in a magnetic field. Electric power. Electric power is the rate at which electric energy is transferred or used. It is measured in watts and is calculated by multiplying the voltage and current, direct current, and alternating current. Direct current, DC, flows in one direction, while alternating current, AC, flows back and forth. AC is used in most homes and buildings, while DC is used in batteries and electronic devices. Electromagnetic induction. The process of generating an electric current by moving a conductor through a magnetic field or by changing the magnetic field around a conductor. Direction of induced EMF Lenz's law. The direction of an induced current is such that it opposes the change that produced it, as described by Lenz's law. AC generator. A device that converts mechanical energy into electrical energy by using the principle of electromagnetic induction. Mutual induction. The process of inducing an electric current in a coil by changing the magnetic field around another coil. Transformer. A device that transfers electrical energy from one circuit to another through mutual induction by changing the voltage and current levels. High voltage transmission. The process of transmitting electrical power over long distances at high voltages in order to minimize energy losses. Thermonic emission. The process of emitting electrons from a heated metal surface. Investigating the properties of electrons. The study of the properties of electrons, such as their charge, mass, and behavior in electric and magnetic fields. Cathode ray oscilloscope. A device that displays the waveform of an electrical signal on a screen by using a beam of electrons. Analog and digital electronics. The two main types of electronic circuits, which process signals in different ways. Basic operations of digital electronics logic gates. The building blocks of digital circuits, which perform logical operations on binary inputs. AND operation. A logic gate that produces a high output only when both inputs are high. OR operation. A logic gate that produces a high output when at least one input is high. NOT operation. A logic gate that produces a high output when its input is low, and vice versa. NAND gate. A logic gate that produces a low output only when both inputs are high. NOR gate. A logic gate that produces a low output when at least one input is high. Uses of logic gates. Logic gates are used in digital circuits to perform various functions, such as arithmetic, memory, and control. Information and communication technology. The use of technology to create, process, store, and transmit information. Components of Computer-Based Information System, CBIS. The hardware, software, data, and people that make up a computer-based information system. Flow of information. The process of moving information from one point to another, typically through a network of computers and communication channels. Transmission of electric signal through wire. The process of sending an electrical signal through a wire by using a voltage difference between the two ends of the wire. Transmission of radio waves through space. Radio waves are a type of energy that can travel through space. We use radios and other devices to send and receive information through these waves, like music or news. Transmission of light signals through optical fibers. Optical fibers are thin strands of glass or plastic that can carry light signals over long distances. They are used in telecommunications to transmit data, like phone calls or internet information. Information storage devices. Information storage devices are devices that can store data, like computers, hard drives, or USB drives. They allow us to save and access information quickly and easily. Application of computer. Computers are machines that can process and store data. They are used for a wide range of applications, like word processing, gaming, and scientific research. 17.9 Internet. The Internet is a network of connected computers and devices around the world. It allows people to communicate and share information, like email, social media, and websites. Risks of ICT to society and the environment. ICT, information and communication technology, can have negative impacts on society and the environment, like cyberbullying or e-waste. It is important to use technology responsibly and safely. Atom and atomic nucleus. Atoms are the basic building blocks of matter. They have a nucleus at the center, which contains protons and neutrons, and electrons orbiting around it. Natural radioactivity. Natural radioactivity is the process by which some elements spontaneously emit radiation, like alpha, beta, or gamma rays. This can occur in the Earth's crust or in space. Background radiations. Background radiation is the low level of radiation that is present in the environment from natural and man-made sources. It is present everywhere, but at very low levels. Nuclear transmutations. Nuclear transmutations are the process by which one element is converted into another element by changing the number of protons in the nucleus through nuclear reactions. Half-life and its measurement. Half-life is the amount of time it takes for half of the radioactive material to decay. It can be measured using special equipment, like a Geiger counter. Radioisotopes and their uses. Radioisotopes are radioactive isotopes of elements that can be used in a variety of applications, like medicine, industry, and research. Fission reaction. Fission is a nuclear reaction in which the nucleus of an atom is split into two or more smaller nuclei, releasing a large amount of energy. Nuclear fusion. Nuclear fusion is a reaction in which two atomic nuclei combine to form a heavier nucleus, releasing a large amount of energy. It is the process that powers the sun and other stars. Hazards of radiations and safety measures. Radiation can be harmful to living organisms and the environment. Safety measures, like wearing protective clothing or using shielding, can reduce exposure to radiation and prevent harm. If you want to learn more about physics, subscribe to EduCyb Edutainment and don't miss out on this opportunity to expand your knowledge and stay informed. Subscribe to EduCyb Edutainment today.